Hey everyone, our topic today is fractions part 6. We're adding fractions with like denominators. Remember, when you have fractions, you have three parts. You have your numerator on top. The number on the bottom is a denominator. And when we say like denominators, we means that we're adding fractions that have the same bottom number, the same denominator. In this case, we have 6. So how that works is that when you add fractions, it's actually pretty easy. You only add the numbers on top. So I'm just going to write a note here is that we do add the numerator, but we do not add the bottom number, the denominator. When you add fractions, the denominator stays the same. There's a little bit of math term for that. It's called boom, boom, boom. In other words, 6, in this case, 6, 6, and that stays exactly the same. Now, the boom, 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 I'm just kidding. It's not really a math term. It's just a little thing to maybe help you remember that. But the bottom stays the same. However, we do add the top. 2 plus 3 would be 5. So our answer would be 5, 6. And the models show that down here. If you look at the blue section here, notice that we have 1, 2, 3, 4, 5, and that is our 5, the shaded part for our numerator. The 6 on the bottom, the idea here is that this fraction has a total of 1, 2, 3, 4, 5, 6. And so does this one has 6, and that's what we mean by 6. Remember, when you add fractions, you only add the numerators, which is your top. The denominator must stay the same. One way to think about it is that if you were adding 2 apples and add 3 more, you have a total of 2 plus 3 is 5, but they stay apples. So that would be the idea there. It doesn't change, you just add the top. What you don't have is you don't have 2 apples plus 3 apples, and then somehow they change into 5 oranges. That would not be correct. So when you're adding fractions, do you add the top? Yes. But the bottom is boom, boom, boom. In other words, it stays the same. It does not change. So looking at this fraction again, 2, 6 plus 3, 6 equals 5, 6. I could show that in fraction strips or a fraction model. So these orange tiles would represent our 6. So here we have 2, 6, which is 1, 2. And here we have 3, 6, which is 1, 2, 3. Notice that when we add them, we have a total of 1, 2, 3, 4, 5, which is our top number. But all of them are 6. The bottom number is telling it what that is. Now, what we don't want to do, so this is how we do it, right? We add the top, but on the bottom, boom, boom, boom. What we don't want to do is say, well, we're going to add 2 plus 3 is 5. And then on the bottom, 6 plus 6 is 12. And then here, your answer would be 5 twelfths. Let me show you why that wouldn't work. Here are 12s, and I'm going to show you 5 of them. Do you see the difference? That's why fractions won't work. If you turn that into 12ths, you have turned a 6. In other words, you've kind of turned, an apple into what? Into an orange. You've turned a 6th into a 12th. And in math, you cannot do that. So I'm going to put my frown face here, and we do not add the bottom. Remember, boom, boom, boom. The bottom stays the same, but you only add the top. You can show this with models. directions. Use the model to find the sum. So this would represent one whole. And then what we have here is I'm going to count our total number of what our denominator is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So all of these are tenths. I'm just going to write these as unit fractions real quickly. Remember, a unit fraction is when we have a fraction with 1 as our top number. All right, so what we're looking at here is when I want to add the green, I'm looking at 1, 2, 3, 4, 5. So 5 tenths. And the yellow would be 3 tenths. And the bottom, remember, boom, boom, boom. In other words, we're going to stay the same. It's actually easy. You don't have to really think it through too much. It just stays the same because they're tenths. You say, what about the color? It doesn't matter in this case. They're still tenths. And then 5 plus 3, if I went 5, 6, 7, 8, our answer would be 8 tenths. Here's another example. We're going to use our model to find the sum. This time I'm looking at 1, 2, 3, 4, 5. So if I wrote these as unit fractions, each of these would represent 1/5. And the blue would be 1/5. The red would be 1, 2. So we're looking at 2/5, right? Bottom is boom, 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 stays the same, but we only add the top, 1 plus 2, and we end up with a total of 3/5, which you can see here, 1, 2, 3. Here's adding some fractions with no models. Again, really easy if we just follow the rules. Boom, 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 right? 12, 12, 12. And if I add 6 plus 5, so go ahead and pause if you want and try these. All right. On this one here, we have boom, boom, boom. So 3/8. These are so easy, right? 10, 10, 10, and 6 plus 3 would be 9 for 9 tenths. 5, 5, 5, and 2 plus 2 is 4. Interesting. Here we have 3 of them, but the rule stays the same. 12, 12, 12, 12. And if I want to use my pin dot strategy, I could say 6, 7, 8, 9, 10, 11 twelfths. And 4, 4, 4, or boom, boom, boom. And 2 plus 1 is 3/4. So hopefully that's helpful. Remember, today our lesson is on adding fractions with like denominators. Like denominators means the bottom number is the same, and we just said 6, 6, 6 in this case, or boom, 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 it stays the same. We don't add the bottom, we only add the top. All right, thanks everybody.